recording now. The log es el común logaritmo que the base is 10. And lm is the natural que the base is e. It doesn't matter what you select. Si es this key or this key, the answer is the same. Okay, so let's do one problem using log, another problem using ln, and we compare both. Why not? Okay, so now, important moment. You apply logarithm on both sides. If you want, you put a parenthesis. I appreciate so much you put a parenthesis. Remember, log is the name of the function, no? This is a function notation that you write normally like that, f of x. Nobody in this notation, the student omit the parentheses, no? But there are no reason to omit the parentheses. Some people omit the parentheses, but okay. Okay, now you apply the property number 7. I explained last class. Property number 7, allow me. Let me copy property number 7. Property number 7, say, you have log or the any base, arbitrary base, of the one expression that I call m, and the exponent is r. And when this situation happens, this exponent fly and put it in the front as a factor. Okay, this is the property number 7. So always we apply property number 7. Why? No, always, but frequently. Because this allows me convert this exponent to a factor in the front. So we have x logarithm of 2 equal logarithm of 3. Okay, so it's unbelievable. At the beginning, we have exponential equation. This is exponential equation. That's the name, technical name of this guy. Now, when you apply logarithm, it's obviously it's a transformation. You have in that moment a linear equation. Linear equation, like for example, 2x equals 3. Okay, you solve in intermediate algebra divided by 2, and that's it. Well, in this case, no 2, but 3. It's a logarithm of 2 and logarithm of 3. But definitely, it's a number, right? So magically, when you apply logarithm on both sides, you need to understand the idea behind this. Is you convert from exponential equation to linear equation. So now, you divide both sides by log of 2, que is a number that we can compute it using the calculator, of course, divided by log of 2. Okay, this is cancel out. This is x alone is equal log of 3 divided by log of 2. Okay, super. And this is the exact answer. This is the exact answer. But in the test, no. In the test, I want the approximate answer. So when it's irrational number like that, when it's a equation that we solve and use a logarithmic, I say compute the approximate answer, approximate answer. A specification, I need, for example, using 4 decimal place. Decimal place. Well, I said just example, maybe I say 5 decimal place, 6 decimal place. But 4 is the most common number, right? So now you put this symbol, indicate approximation, and you put in a calculator, something like that. Look, let me try to explain the calculator. Everyone follow me, please, please, please. Suppose that this is the display of my calculator, this box. I have in my hand right now one calculator exactly like this picture. Yeah, I click on the key LOG, is that key. But let me use a record, maybe that key guy, LOG. Okay, so I see in the display right now. That idea. LOG parentheses. So automatically, when you press this key, The calculator put in the display log and open one first parenthesis. Well, okay, so you type in 3, close the parenthesis, very important, extremely important, close this parenthesis, division, divided by division. Again, press the key log, open new parenthesis, and you put 2. And close the parenthesis. And press enter. Or equal, doesn't matter. And the answer in my display now is 1.5849 62501. At least in my calculator. Another calculator have more decimal or less decimal. It doesn't matter. I want 4 decimal. So now I copy the big number. The big number. I copy the big number. 58, sorry. I copy the big number. Okay, I saw in the display of the our calculator. Okay, but the problem say the professor said he want 4 decimal place. 1, 2, 3, and 4. And you round off. If our next digit is 6, actually is 5 or greater than 5, you increasing +1 the previous digit. Entonces 9 + 1 is 10. Entonces actually my answer is 1.5850. 4 decimal place. End the story. Any question? You did that in your own calculator or no? This is clear, confusing?
Clear.
Eso, bueno. Okay, therefore we practice. I bring a lot of examples today. Next week after the holiday, you know, the Thursday is holiday, no school, no class. Obviously, we continue with the application of this application. Apply this again. Okay. Let's do an example 2 now. Example 2 now. Let me erase that part also. Why not? Okay. Let me erase that part. I forgot to say that the same answer you can get if you using no L or G, using LM. Let's do in that problem using LM. Okay, example 2 now. Example 2, say 5 parentheses 2 to the x equal 8. Solve this equation. Solve mean find the x value to satisfy this equation. Okay, this is easy. It's similar to the first. But I introduce a little bit modification. Is you have to isolate the exponential part. Sorry, I make a mistake. The mistake is that the exponent is no x, it's 3x. 3x. Okay, so the new thing is you try always to isolate the exponential part. So you divide by 5. The equation. Divided by 5. So far, in the second line, we have 2 raised to the 3x is equal a/5. Entonces this is a crucial moment in which you apply the logarithm of both sides. What kind either? In this case, by curiosity, I want to apply ln. Pero no mandatory, guys. You don't like ln, I don't force anyone. You apply LOG all your life, and you have no problem. But okay, I want to illustrate the potential of both. You apply this, both sides. And use it one more time, the property number 7. Allow me the exponent go to the front as a factor. over 5. And finally, solve for x. So I propose you divide both sides by 3 ln 2. It's just a number that I can do that in the calculator. Okay, entonces x alone is equal ln of a over 5 divided by 3 times the subject time, the operation in between. So normally when the one arithmetic symbol is missing, it's because it's time. But okay, we put a period, ln of 2. Okay, beautiful. This is my exact answer. But in the test, I want approximation. So I put in the calculator. Approximate in the calculator. Okay, let's do it. So I want to simulate again the display. This is the display. I want to guide you to be familiar with the you typing this. So now I'm putting on my calculator, clear the display, clear, display clear. Okay. Now I put the top part, and the top part is ln. Okay, I press the key ln. So it means I see in my display ln parentheses. Okay, I put a divided by 5. A divided by 5 division symbol, close the parentheses. It's important you close the parentheses because this close the parentheses indicate me when they finish the line. But the line starting A, but finish 5. And in the middle, we have division because it's a fraction. Divided by another division. Okay, it's the same side. I don't know, I put a long side. It's the same side divided by. Okay, it's same side. It's the same side of this because the calculator have only one side. And be careful now. Be careful now. You open another parenthesis. Why you open? Well, because I need to indicate the order of operations. So my recommendation is when you have two guys in the denominator, you would open the parenthesis. Because you don't open the parenthesis, the calculator is not smart. Understand that you divide by 3 and after multiplication by ln 2. No, you type in 3, multiplication and the calculator is after. Okay, and ln of 2. ln of 2 and close to parentheses. What parenthesis? The parenthesis que open the second logarithm, close, the parenthesis que close this parenthesis que I try to enclose everything in the denominator together, no? Okay, I press enter. I see that solution. 0.226023.968. You check and see I make a mistake because I frequently make a mistake, you know? 226023.968. Okay. I did okay. 4 decimal place. I need my final answer. 1, 2, 3, and 4. No problem, because the next digit is 2 is less than 5. So you ignore totally that one. Boom. My final answer is 0.2260 and end the story. Final answer. Any question, guy? How do you feel? Come on, opinion. You feel okay or feel strong? You feel weak? You don't understand anything? I need to explain again? Oh, no? No? Sure? All right, opinion. Come on, activate the microphone or using the chat. Everyone follow me? Union. Rebecca, yes. Okay, follow me.
Yes, sir.
Okay, Yaeli, well, you follow me? Answer me, please. Yaeli. Okay, no problem. Let me complicate a little bit your life. Now, let me complicate a little bit your life. No, not too much. No, don't be scared. Not too much. Not too much. Only a little bit more interesting example. Not too much. All right, let me see what is your comment in the chat. Okay, delete that part and erase that part. Okay. Let me see the comment in the chat. In the chat say here. Okay. Remember to record. Okay, I did that. One more thing. Good afternoon. Follow. Okay, no problem. So I suppose that everyone understand very well, no? Okay. Do you see the whiteboard, right? Or no? Do you see or no?
Yes, sir. I see it.
Okay. So now let me try to erase that part. Okay, the next example number 3, is more interesting. Look, is 0.3 is the base raised to the 1 plus x is equal 1.7 raised to the 2x minus 1. Exponential equation. And the base completely crazy. The base of this exponential is 0.3 and 1.7. Okay, this is impossible doing using the traditional way. Because 0.3 and 1.7, 0.3 and 1.7 never we can express it using the common base. No, never, impossible. However, I have my calculator and I know that this equation we can solve it using logarithm. Entonces, one more time, we're using this logarithm. Common, LOG. Okay? Let me try to apply both sides. LOG of this. And LOG of this. Okay. And one more time, we apply the property number 7. And the property number 7 allow me this exponent get 1 plus x go to the front like that. 1 plus x. Entonces, I highly recommend put the parentheses because this expression, the binomial, is multiplied times LOG of 0.3. Likewise, 2x minus 1 times LOG 1.7. Okay, this is just a number. Don't be scared. A number and a number. We are, of course, irrational, but we can compute it in the calculator, no? Okay. The rest is algebra, but basic algebra, intermediate algebra. You distribute the property, so this number you multiply this and this. Entonces you have logarithm of 0.3 times 1 stay the same plus x times logarithm of 0.3. That is the situation in the left hand side. The situation in the right hand side similar. Multiply this and this, multiply this and that. The 2x times LOG 1.7 minus LOG 1.7. Everyone follow me? Entonces, exactly the same we are doing intermediate algebra. See, my goal is solve for x. You need to move every term can contain x to the one side, left or right, doesn't matter. And the other guy do not contain x in the other side. Entonces, I make a decision, not necessarily is the only way to do that. For example, this guy stay. This guy can contain x, look, contain x, stay here. x log of 0.3. I bring 2x logarithm 1.7 to the left, like a minus 2x logarithm of 1.7. Okay, and the right hand side of our equation will stay negative logarithm of 1.7, just bring down, copy and paste, and move minus log 0.3, que is located previously in the left hand side, but I moved to the right hand side. When you move to the right hand side, the sign change. Super. Okay. So now I can see in the left hand side we have x and x. This is was my intention. You factor out. This x you factor out. Open parenthesis, we have log 0.3. Don't forget the parentheses. Minus 2 log 1.7 is equal something. Yeah, you just copy this. Okay. Okay, I forgot another parenthesis here because I opened this parenthesis. Yeah, I closed this parenthesis. Okay. Now, finally, why not? Divided by both sides by log 0.3 minus 2 times log 1.7 because I want to isolate x. Sorry, guys, I know it's too long, but it's important. Now, it's obvious. That that part cancels out. It's gone. And it's the x alone. And x alone is minus log 1.7 minus log 0.3 divided by log 0.3 minus 2 times log of 1.7. Okay, you can put this in the calculator, but no, I do not recommend it because we know another property of the logarithm and we can condense it. So when you have in the expression several logarithms, 1, 2, 3, 4, we have 4. Wow, not good. Put in the calculator. You put only 1 or 2 at least. So first of all, I propose you one fantastic idea. Number one idea is there are no reason to have too many negative, 3 negative. You multiply by -1, top and bottom. And our answer doesn't affect by multiplication by any number in the top and the bottom. So we have log 1.7 positive, good, I like that, plus log 0.3 positive, I like that, and divided by, well, I change the sign this, because I put 2 log 1.7, now positive, minus log 0.3. Do you see the idea or no? This is totally optional, okay? Suppose you don't like this, no problema. You put it in the calculator like that. With the negative, positive, this is optional. I highly recommend do that. However, well, it's up to you. And leave it like that, no? Continue. I continue transformation. Look, I continue transformation. I know the property number 5. I want to recall property 5 of the logarithm base. Logarithm of the any base of the multiplication through expression is equal to the sum of the logarithm separately, m times plus. I can see something similar of this. Look, we have the sum, 2 logarithms. There are no reason to have separately. No. I copy together. I copy x equal only one condensed in only one logarithm and inside. So we can apply that property in this direction or in this direction. And this direction is like a decomposition in several. But in this direction is condensing. You condense it, two logarithms in only one. And the only one is the multiplication, 1.7 and 0.3. Immediately I put in a calculator, in my calculator, I put 1.7 times 0.3. And the answer is 0.51. Wow, I like that. Because I don't need to compute the two logarithms separately. No, only one, condensing only one. Likewise, or similar, in the bottom, I recall one more time the property number 6 is similar to the property number 5, but the property 6 is division. The logarithm of a, m divided by m, is equal logarithm of base a of m minus logarithm of base a of m. Now, when you have subtraction like that, minus, look at that, minus, is division. Recall property number 7, we used them before. Logarithm of base a of the m to the r is equal r times logarithm of base a of m. So basically, well, this is the property we used at the beginning, no? Is the exponent I put on the front as a factor. Okay, I take advantage. Look at that. I condense it in only one logarithm of the bottom part. But it's a little bit complicated because it's 1.7, get the positive r, square. These two go to the exponent divided by 0.3. Something like that. Okay, personally, I like to compute this first of all. Doesn't matter. Well, okay, yeah. I put in a calculator the auxiliary calculation. I put log 0.51. Well, yeah, why not? And logarithm of, so I put in my calculator 1.7 square, 1.7 square. My calculator have one key gets a square directly, divided by 0.3, divided by 0.3. Boom. The answer is 9.63 repeated, something like that. Everyone follow me so far, or you are confused in one step? Just in case, to make sure everything is okay, this number gets half infinity decimal, 0.333333. You can use the memory, store memory, but it doesn't matter. Store memory A, for example. I did that. Clear. I want to my calculator. In my calculator, we have, look. So I actually saw the majority of the most of calculator have memory. This number gets 9.633333. I storage STO key in the memory A, for example. So now, when I call A, memory bar, A and 9.6. Okay, so I don't need to type again. That's no good. Okay, now, again, we come back to our display. In our display, we have display. Okay, display say log, no, it's log, yeah, it's log. You press log, parentheses when you press this. Inside the log, you put 0.51, and close the parentheses. This is the top part, 0.51. Divided by log again. Sorry, I make a mistake. Okay, no problem. log again. Log of what? Log of this weird number is 9.633333, but in this case I storage in the memory A. So I put the memory A, memory bar, memory variable, I select A, and close the parentheses. Boom. And press enter, and the answer is, wow, negative. I see in the display negative 0.2972 72, yeah, 5227. I need 4 decimal place, for example, is 1, 2, 3, and 4. And the next digit is 5. When you round off, increase it. So the answer is negative 0.2973. Done. Final answer. End the story. Okay, let me try to understand. Professor, make sense. Okay, my answer is negative. Yes. How do you know that my answer is negative? Look, you need to know one idea. When you apply logarithm of the number less than 1, 0.51, the answer is negative. The logarithm of the number less than 1, 0.51 is less than 1, is negative. And logarithm of 9.63 repeated is positive because it's greater than, because the argument of the logarithm is greater than. And negative divided by positive is logical, is negative. Boom. Final answer. Clear or confusing? Sorry, I know it's too long, but it's not my problem. It's not my problem. Any question? Any question? I need to understand that you are clear to continue, because this is more complicated, more complicated, more complicated. Some students never understand logarithm. You say, I hear, I never understand this, I never understand. Okay, sorry. This is called algebra. This is called algebra. Everyone follow me, guys, or no? Daniel, you follow me? Carolina? Come on, answer. Follow me. Okay. Okay. Dice Kemely Alfonso.
Yes.
Okay. Clear for this, okay? Everything okay? Okay, super. Super. You are good students.
Yes.
Okay, guys. Because I want to erase. Okay. I want to erase the board. Complete. I suppose that the picture of the calculator you don't need to understand this. Let's move on to example 4. A little bit complicated. Example 4 is this example. Look, it's 4x, 4 raised to the x power minus 10 times 4 to the minus x equal 3. Suppose this example. This is very confusing, but don't worry. I explain it then. So you have no idea how you face that. However, I recommend eliminate, reduce, clear the negative point. The negative point is not good for me. Well, how we can do that? Well, multiply the entire equation by 4 to the x. You multiply 1 by 1 by 4 to the x, you multiply 4 to the x times 4 to the x is 4 to the x squared. Minus 10 times multiplied by the second element, is this. Is 4 to the minus x times 4 to the positive x equal 3 times 4 to the x. Okay. So now, look, you apply the property for the exponent, you put 4 to the 2x, because you know that when you have different level of the exponent, suppose that we have x to the second to the third, is equal to x to the 6, because you multiply 2 times 3. In this case, you multiply 2 times x is 2x. I put in this order because I like the coefficients numerical first. Now, this is just saying why, Professor? Because when you apply this as 4 to the minus x times 4 to the positive x is 4 to the minus x plus x is 0. And 4 to the 0 is 1, and 1 is invisible. This is 1, and stay alive only negative 10. Equal 3 times 4 to the x stays the same. Okay, okay, okay. I have no idea how we continue, but at least I eliminate the negative part using this idea. Okay, so I remember something the professor explained in the chapter 1, is the equation quadratic in 4. This is equation. It doesn't matter the nature of this equation, but the important thing is that we have two exponents. Suppose in this case minus 10, if the coefficient is equal to 0, and you have something here, but the coefficient here is twice than this. Oh, yes, this is 2x and this is x. Professor, how you solve this kind of equation? Well, I remember that we are using substitution. You change the variable, u is equal to something, and the lower exponent. Okay, so you, for example, in this example, use that substitution is u. You remember it's the auxiliary variable. It's equal 4 to the x. How do you know it's 4 to the x? Because the exponent is lower is x, because this is 2i, double. Entonces, it's okay. Okay, entonces now, see, this is double, this is u squared. Okay, minus 10, do not contain x, no contain u, is equal to 3u. Wow. And this equation, when I put in standard form, u squared minus 3u minus 10 equal to 0 is just quadratic equation. Super easy. Do you see the transformation or no? Do you see or no? Sign fiction or no? All right, let me see the comment in the chat. In the chat, you say, I don't understand anything. I know, yes. Okay, you understand? Okay. Good. Okay, now, solution of this quadratic equation is a piece okay for us. I suppose it's possible doing by factorization. I suppose. Because 10 and 3 is u, 5 and 2, no? 5 times 2 is 10, 5 minus 2 is 3. What sign? Negative 5 and positive 2. Okay, therefore, u minus 5 is equal to 0. Therefore, u is 5. Nice, I like that. I split the paper into two parts. U plus 2 equal to 0 is because u is negative 2. I think, no, remember my goal is solve for x, get the original variable, and u is the intermediate or auxiliary variable to help me to convert the exponential equation to quadratic equation. Okay, so now how you restore the original variable? Okay, what is the connection? The relationship is this. Question, look at that. The connection between u and x is this. Okay, so u5 is 4x equal 5. And the other is 4x equal negative. Okay, now we are ready to solve for x, que is our original variable. Okay, so one more time, you face two exponential equations. Two exponential equations is impossible doing in the traditional way. You need to apply your logarithmic. What kind? Either logarithmic standard, because I solving in my calculator. You apply, for example, natural, both sides. Okay, you apply the property number 7, and the property number 7 allow me to put x in the front as a factor, and the answer is logarithm of 5 divided by logarithm of 4. This is my final answer, expressing exact solution. Okay, but in the application, in the real life application, somehow involve this kind of equation. You see in next class after the sum giving. Obviously, this number don't say anything. Suppose get money, how many dollars? I know, I have no idea. So I need to put approximation in our calculator. So I need the final answer in approximation. I put in my calculator. I do in my calculator now, putting on, clear the display. You put, for example, let's use a natural, no? Natural, because ln of 5. Close the parenthesis. Don't forget to close the parenthesis. Divided by ln of 4. Boom. And the answer is positive. The answer is 1.116. 1.16, sorry, 0.96447. I recommend, guys, copy directly in the calculator. So you see how many decimal place you need. Oh, you need 4. Okay, no problem. 1, 2, 3, 4. What is the nature of the next digit? It's 6. So you increase. So actually, my answer is 1.1610. No? 10 because it's 9 plus 1 is 10. So you add in 1 here. Boom. It's 10 carry the 1 is 1. This is my final answer. Oh, no, this is my final answer of the first part. Remember, we split the paper into 2 pieces. Now we take care of the second piece. And the second piece is, wow, it's weird. Because the professor, when explaining the exponential function, the lecture of the exponential function, I remember that the exponential function looked like that. And the exponential function never could be equal to -2 because -2 is a line, -1, -2 over there. There are no intersection between this exponential function, y equal something, and y equal -2. There are no intersection. So I suspect that we have no solutions. But I'm not 100% sure of this idea. Why not? Let's do it in the same way of this. You apply logarithm both sides. Oh, but I remember one more information. The professor, when explaining logarithmic function, explained me that the domain of the logarithmic function is only positive number, no zero, no negative. Because that is weird again. I suspect we have no solution. But okay, I continue. I move the exponent to the front. Okay, I compute that. And those x divided by s logarithm of -2 divided by logarithm of 4. Okay, ready to put in the calculator. Clear the display. You put ln of -2. And be careful, guys, because in the calculator we have two negative. No, the negative in blue color is subtraction, and the negative in the white color is negative. No, actually this is white color, -2. Close the parentheses, divided by ln 4. Close the parentheses, present. Boom! Domain error. Is the answer I saw in the display. I make sense. I predict this. Domain error. Because -2 is completely out of the domain. Entonces, no solution for that part. It's a predicted look, no solution, not necessary to write anything. Okay, now we have only one solution, is that solution in the story. That solution is the only one solution that we have in this equation. Any question? I promise in the review package, of course, we'll go over again to the more complicated exponential equation que is solving using logarithm. Okay, any question, guys? Super clear? Come on. Okay, good. Let me see. Clear. Okay, let's move on now to the logarithmic equation. So we are doing now logarithmic equation. Logarithmic equation. Okay, I type in that. Now let me see here, over there. Logarithmic equation. Okay. This is similar, but this is a little bit more, you know, complicated because the exponential equation is nice. What is the reason that exponential equation is nice? Because the domain of the exponential function is all real number. However, logarithms no. Logarithms do not accept negative value inside the domain. For this reason, it's mandatory, similar to the situation that happened in the radical equation. Do you remember radical equation? Radical equation, I found solution, but you need to check in the solution in the original equation. Similar situation happened. In the logarithmic function, you find solution, but this solution is potential solution, and you need to verification in the logarithm. Mandatory, because sometimes fail, sometimes pass. Okay? Mandatory checking the solution, the potential solution, and the logarithmic equation. Let's do it. I bring you one example. Look, logarithm, example 1 of the logarithmic equation. Suppose logarithm base 3 of x plus logarithm base 3 of x minus 24 equal 4. This is my equation. It's given in the test. In the test, I have no idea. I put any base, 3, 5, 2, 10. So we have some equation that is a natural logarithm or common logarithm. Okay, you need to be aware for any base. Okay, this is the procedure is always the same. Step number 1, condensing the logarithm statement, or the equation that contains 2, 3, 4, 5, condensing in only one logarithm. And one more time, we apply the property number 5, que say the logarithm of the any base of the m times m is equal logarithm of base a. The base should be, no, must be the same of m plus logarithm of base a of m. But actually, we apply the property in that direction because I want to condensing this and only one. So the word log base 3, you write only one time. Entonces you open parenthesis and inside you put the multiplication, this expression, times this expression, is x minus 24. Something like that. I put double parenthesis because this outermost parenthesis indicate the argument inside. And we have another parenthesis here, que es the binomial. Monomial, no necessary parenthesis. Well, you put it, it's okay, but not strictly necessary. Equal 4. Okay, let me copy again. Log base 3 parenthesis x times x minus 2 minus 24. Sorry, it's 24, no? It's 24. I copied wrong. Equal 4. Okay, forget about this. This is a mistake. Okay, I condense this. Everyone understand this idea? Always is the same. You have, how many logarithms you have? You have 2, condensing 1. You have 3, condensing 1. You have 5, condensing 1. Okay, now pay attention now, because the most important moment. Okay, we have here logarithmic statement, and you convert to exponential. And you put exactly the same in the test. Yeah, I understand very well this symbolic way. So you put an arrow, and you put 2 exponential. It's conversion. Logarithmic statement to exponential statement. And remember, the idea is you ask by yourself, what's the base? The base in the logarithmic statement is 3. I put the big 3 because now in the exponential statement, the base normally is the big side number, right? What is the exponent? What is the exponent? Well, the exponent, professor, is the answer of the logarithm of 4. And what is the result? Oh, the result is the algebraic expression is x times x minus 24. So, guys, this statement and this statement is equivalent 100%. It's the same thing written in different language, exponential and logarithmic. But maybe in the exponential is more clear, no? To understand, I suppose. Exponential. Okay, you convert logarithm to exponential. Okay, 3 to the 4 power is 3 times 3 times 3 times 3 is 81. And you apply distribute here is x squared minus 24x. Wow, this is quadratic equation, professor. So x squared minus 24x minus 81 equals to 0. I put in standard. Entonces now, by factorization, oh, I have no idea. Maybe quadratic form is much better for me. Identification que A is 1, B is negative 24, and C is negative 81. And you apply the quadratic formula for solving the quadratic equation. Okay, 24 positive because double negative, you know. Plus and minus square root negative 24 squared minus 4 multiplication by 1 multiplication by negative 81 que C, everything divided by 2 times 1 is just 2. Okay, one more time I need to use a calculator, of course. 24 squared, well, negative 24 squared, you know, when this is negative, doesn't matter, it's positive, no? Because you clear the display. You put negative 24 squared, it's obviously positive 576. Wow. Be careful now with the sign. We have double negative here, and negative here. Therefore, the answer is positive. Positive what? Positive 4 times 81 is 324. And 324 plus 576 is 900. Wow. And the square root 900 is 30. It's easy to understand because radical 9 is 3, no? And 2 0 is 1 0. I'm sorry. Well, you put it in a calculator, no? Not necessary by memorize this. And so far, my answer is 24 plus or minus 30 divided by 2. Let me separate. 24 plus 30 divided by 2 and 24 minus 30 divided by 2. Okay, 24 plus 30 is 54. 54 divided by 2 is 27. Okay, this is one potential solution. And 24 minus 30 is negative 6. And negative 6 divided by 2 is negative 3. Okay. That's it. I gotta go. I finished. No. I need to see the important thing part is the checking part. You need to verify checking both solution 27 and negative 3 inside the original equation. This equation. Okay. So I go to the 27. I go to the 27. X equal checking 27. Verify 27 inside the region. And to say I need to manipulate this statement, logarithm by 3 of 27 plus logarithm of base 3 of 27 minus 24 should be I claim this 4. I have no idea see this is a true statement or false statement. Okay, let me try. Of course, we use a calculator if you want. Logarithm by 3 of 27, okay, plus Logarithm of base 3 of 27 minus 24 is 3. Should be 4. You can put in a calculator, but no. What's the problem? The problem is that normally in our calculator we have standard base, it's 10 or E, not 3. Some calculators allow using any arbitrary base. But no. Well, in this case, it's a little bit complicated, maybe. However, I apply one more time the property number 5, in which you condense this in only one logarithm, not necessarily two separately. Logarithm is 27 times 3. And 27 times 3, I put in the calculator is 81. Logarithm of base 3 of 81 should be 4. Well, okay, one possibility is, I explain any possibility. In order to verify that this statement is true or false, you convert to exponential one more time. To exponential. The base is 3. The exponent is 4. Remember, the exponent is the answer for the logarithm should be 81. So big, yes, it's true, super true. Super true. So 27 is good answer. Okay. Another way, guy, another way. I encourage you to do another way. Look, because we have many options in the test. Okay, you, for example, and your calculator, you cannot compute this. No. Because my calculator have only standard base, log or LM. But you using the famous change of base formula. Okay, I want to repeat again. Formula. The change of base formula say logarithm of the any base of the one guy, I call x, that's a number, is equal to logarithm of the another base of the same number divided by logarithm of the same base, can be BP, but of the a. Suppose that I have no possibility doing the calculator base 3. Okay, no problem. Using everything 81, I copy x, is x in my formula is 81 in our specific example, divided by log of 3, case A. Okay, so you put in the calculator, let me see, log of 81, close the parenthesis, division. So I put in the calculator, display something like that. Look, log 81, close the parenthesis, division. Be careful. The majority of the students make a mistake, put like that. Logarithm of 81 divided by 3. No, because you close the parenthesis to indicate only the logarithm of 81 and log of 3 separately. Okay, and the bottom we have log of 3, close the parenthesis, of course, and press equal. Bang, that's 4, the answer. The answer can give me the calculator 4 is equal to 4. Super good. Okay. What about negative 3? Well, negative 3 is a stupid answer. Because when I try to do the checking for x equal minus 3, look, logarithm of base 3 of negative 3, you say, wow, I know very well. Okay, logarithm do not accept negative number inside the argument because the domain is only for the positive number. So this is completely wrong. And our final answer is 27. That's it. This is the final answer for our problem. This is the only one solution we have in this problem. Super good or super bad? Everyone follow me or no? Clear or confusing? Wow. Okay. Kind of confusing. What part? Hold, I repeat again for you. Anything that you need to know. What part is confused? So you don't need to know any possibility. I am a teacher, no? Teacher explain for that way. No. So you suppose. So normally, when I teach that part, I ask you to, what do you prefer? Doing by hand, using the property, or putting the calculator? The majority of the students say, no, calculator is good for me. It's good for me. In your case, Clifford, do you understand very well the verification using the calculator or no? I want to repeat again for you, no? Okay, what do you say? What do you say? Yes. But I don't hear, I don't see very well. Repeat again, please. Clifford. Because in this moment, when you answer me.
When you say you have different ways of checking your answer, that's the part I didn't understand. Like the different ways you're doing it.
Okay. And the first part, well, let me indicate in the whiteboard. That part was good for you or no?
Yes. Yes.
Okay. Entonces, the majority of the example we can do using that way. However, suppose you don't remember very well the property for the logarithm. Okay. Suppose we finish the problem in this idea. Logarithm base 3 of 81. Entonces, the problem is, we can compute this in the calculator. This, yes, we can, but a little bit sophisticated because you need to apply the chain of base. So normally, the majority, 99% of the calculator is available in the marker, we have a standard logarithm, common or natural, never base 3. Some calculator, yes, the majority, no. Entonces, to using the calculator, if you want, you apply the formula. The formula say, well, okay. You copy log standard of the 81 divided by log standard of 3. Where come from 81? 81 is this guy, 3 is this guy, and you get 4. Similar ideas, you apply ln 81 divided by ln of 3, you get the same answer. You did in your calculator, Mr. Holmes, or no? I tried to guide you. You did or no? Repeat again, please. Because
yes.
Yes. Entonces, that, okay. So either way, or you using the calculator and verification, or no, you apply the property, you condensing, using the common sense. Well, no, the common sense, no, the convert to exponential statement, no? And you see, wow, it's easy because 3 to the 4th power is 81. Because 3 times 3 times 3 times 3, 4 times is 81. Now it's clear or no?
Yes.
Let's move on to the other example. Maybe you will feel more comfortable when I am doing this. Example 2 of the logarithmic equation. Guys, the application, you see exponential and logarithmic equation. Then you need to be strong. And the word problem, nobody indicate you what is a procedure. You need to know this procedure. Okay, suppose this minus logarithm of base 2, x minus 5 equal 4. Suppose it's given in the test something like that. Logarithm of base 2 of one expression is 3x minus 2 minus logarithm of base 2 of the one expression is x minus 5 is equal to 4. Solve for x. Solve for x. Okay. The procedure is always the same, 100%. Number 1 step, condensing this logarithm and only one. But the difference with respect to the previous example is plus, and you apply the property number 5. Now as minus, you apply the property number 6, and the property number 6 say, I want to copy again. Logarithm of the base is division, m divided by m is equal logarithm of base 8 of m minus logarithm of base 8 of m. Actually, the thinking we have in our equation is subtraction, and when you apply this in this direction is division. And when you condensing this logarithm only one, you have inside the argument 3x minus 2 divided by x minus 5. And everything is inside the argument. Okay, this is super important moment. Condensing. Si you have 3 logarithms, condense in only one. Si you have 5 logarithms, condense in only one. Using the famous property, you know what is the utility of the utilization of the property, guys? Super important property. Now, crucial moment, convert to exponential to see much better. Convert to exponential statement. Okay. So I asked by myself, what is the base? And this logarithm statement. Oh, the base is 2, professor. I put the big 2. What is the exponent? The exponent always is the answer of the logarithm statement. I put a small 4. Equal the rest. And the rest is 3x minus 2 divided by x minus 5. Okay. And this equation, of course, is not exponential, actually, because this is a numerical value. And 2 to the 4th power is equivalent to, say, 2 times 2 times 2 times 2 4 times, okay, 16. So my equation so far, I copy right here, is 3x minus 2 divided by x minus 5 equals 16. And this is the algebra. This is the classical intermediate algebra. You apply, for example, cross multiplication, you multiply like that and like that, because I don't like the fraction. So you eliminate the fraction using cross multiplication. You multiply 3x minus 2 times 1, stay the same, and 16 times x minus 5. Good. So I have the equation in only one line. Now distribute. This is 16 x minus 80. It's 80, huh? Yeah, it's 80. 15 times 5 is 80. Okay. Now, what should I do? Well. I move the variable to one side, the number to the other side. For example, there are many ways to do that. However, 3x stay here. Why not? Bring down minus 16. Okay, I move 16, que is located on the right-hand side to the left, is equal minus 80 plus 2. Okay, you grouping. Variable in left. All right, it doesn't matter. And you combine later. This is negative 13. And this is negative 78. Divided by negative 13 both sides. X alone is equal division. Then negative divided by negative positive is 6. The answer is 6. And that's it. No. I need to verification. Where? In the original equation. I need to verify in the original equation. Verify is important part of the solution. You solving in the test and not verify, 0. Okay? Okay, so now plugging in 6, okay, it's only one solution. No, see, this solution doesn't work. It's because my equation have no solution. See where to say 6 is a solution, but I need to verify. So now checking part at x equals 6. Plugging in. Logarithm base 2 of 3 times 6. You replace x for 6. Minus 2 minus logarithm base 2 of 6 minus 5 should be 4. Okay, let's do the operation inside the parentheses. This is 18 multiplication, 18 minus 2, 16. Logarithm base 2 of 16 minus logarithm base 2 of 6 minus 5 is 1. Is equal to 4. Bueno, the professor explaining the property que logarithm 1 is always 0, regardless the base. Doesn't matter si es base 2, base whatever. So this guy is 0. So I need to prove somehow the logarithm of 2 of 16 is equal to 4. Then you have two possibilities: calculator or by hand. What do you want? Both? Let's do them both, no? What do you want first? By hand or calculator? Come on, guide me. What do you want? By hand or calculator? Holmes. What do you want? By hand. He said by hand. Okay. By hand is, well, I have no idea. But one more time, why not? You convert this statement, gets confusing for me, to exponential. So when you convert to exponential, I realize that the base is 2. I copy this small 2 like a big 2. The exponent of 4 is equal to 16. Is the result inside this. And this statement is true or no? Yes, it's true. It's super true because 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. This is a true statement. And that's it. X equals C is super good answer. And in the story. Do you want to verify with the calculator or no? No? Yes or no? I suppose that's the last thing I want to do today, no? Okay, go ahead. Calculator now. Yes, yes, professor, yes. So now it's doing the calculator. The calculator, suppose I am not good in the property conversion, exponential to logarithmic. Okay, I put in the calculator something like that. I put in a calculator. This is the display of my calculator. Look. You put in a calculator something like, help me. Everyone do it together, right? You put in a calculator, log, because you apply chain of base, no? Actually, I can put in the calculator using a standard, no? Logarithm 16 divided by logarithm 2. How you put in a calculator this? You put logarithm 16 divided by log of 2. Let me try in my own calculator. Okay, clear. Log 16, close the parenthesis, division. Log of 2, close the parenthesis, present, boom, the answer is 4. Okay, you prove using the calculator, okay, this is 4, because I did using the calculator equal 4, true statement, the solution is perfect. Any question, guys? Super good or super bad? Okay,